coming up on Thursday. Just an FYI. What else do we have coming up? Our test is coming up next week. So that we have plenty of time to do that test, I broke it up into a 2-part test because I don't want y'all to feel rushed. Today we're getting into section 8.6, which focuses on solving. Yes, we skipped over 8.5. Yes, we will be going back. 8.5 is kind of a weird one that does not need to go before 8.6. This order just feels better. So 8.6 is all about solving rational equations. So you will want a calculator today. It doesn't have to be a graphing calculator, but a calculator. Now, when it comes to solving rational equations, there are actually a lot of different techniques to do it. Solving rational equations can become by turning it into a proportion, by making it a fraction equal to a fraction and cross-multiplying to solve. Solving rational equations can be solved by equating the denominators, getting the denominators to be the exact same and then ignoring the denominators. Or there is one other method that, in my experience, tends to work better. Because as you deal with rational function solving, one of the things that you're going to come across sometimes is you're going to make the equation more complicated to the point where all of a sudden, if you want to solve it, you're going to have to solve by factoring something to a 4th power or a 5th power or higher even. And that's not fun. So this method of solving tends to be the most streamlined. It tends to avoid getting any excessively high exponents. The one downside of it is people mix it up with adding and subtracting. So you must be careful to not do this when you are simply trying to add or subtract. Now, the best way for me to describe how to do this problem is for me to go through a problem and write the steps next to it. If you haven't figured out by now, I don't often give step-by-step instructions. I find that that limits us a little bit. But for this, I do give step-by-step because of the fact that I don't want it mixed up with adding and subtracting, and also it just helps it make sense a little bit more. Now we're going to start off with one that's a tad bit easier. Now, as I've already said, there are multiple ways to solve these. In fact, on this particular problem, us solving it the way that I'm going to show you to solve it is probably not the easiest way to solve this particular problem. But in the grand scheme of things, it does tend to be the easiest overall. So, if you are wanting to solve, the first thing that we are going to want to do is to find the least common denominator of all of the fractions. Now, if you want to find the least common denominator, if the denominator has addition or subtraction in it, what might you have to do? Put things in parentheses, whether it be by just straight up putting them in parentheses or factor if necessary. Can I factor any of my denominators here? No. So I straight up put the x plus 3 in parentheses because I need to remember that that is one whole thing. Okay, finding the least common denominator. I look at monomials first. My monomials, I have technically a 1 in front of the x plus 3. Not helpful. But I have 6 and 18. What's the smallest thing both 6 and 18 could both commonly be? 18. I can turn a 6 into an 18. And for binomials, what do I need? X plus 3. Okay. The next step is where it starts to become iffy between what we can do here and what we can do with addition and subtraction. If we were simply adding a couple of fractions, if this was a plus sign right here instead of an equal sign, or a minus sign, it doesn't matter which. Once we find the LCD, what is our next step when it's just adding and subtracting? Make the bottoms the same. Get the common denominator on everything. When we're solving, we do not need to do that. Is that a way of solving these problems? Absolutely. Again, it's one of the ones that tends to cause bigger issues, though, because it gives bigger problems. The reason that we have to do that when we are adding and subtracting is when we're adding or subtracting, there's no way to change the fact that they are fractions, and they are going to be fractions at all times. But when we have the ability to solve, when we have an equal sign involved, we have other tools at our disposal. I'm going to simplify this down to a really easy rational equation that we want to solve. If we wanted to solve x over 5 equals 7, what would you tell me to do? Times by 5. And that gets rid of the fractions altogether. In solving, we are allowed to take fractions and get rid of the fraction. We're allowed to do that because of properties of equality allow me to do something to both sides of the equation without changing what the equation is equal to. It changes the fractions, but it doesn't change the equation. So, our next step is to get rid of those denominators. And it is to multiply all of the fractions by that least common denominator. This is essentially multiplying by the same thing on both sides of the equation. Because multiplication, if you multiply one thing in the equation, you multiply everything. Isn't it? So I'm going to multiply this equation by 18x plus 3. Sorry, this fraction. And this fraction by 18x plus 3. And this fraction by 18x plus 3. Now keep in mind that if I'm just multiplying by that, that is in itself a fraction. It is 18x plus 3 in parentheses all over what? 1. And when you multiply fractions, you multiply the tops, you multiply the bottoms, but in the meantime, you can cross simplify. If I just look at that first fraction, can I cross simplify? Is something going to cancel out of the top and the bottom of the fractions? The x plus 3s are going to be gone. And I'm going to be left with 4 times 18. Second fraction, can I cross simplify the 5 over 6 times the 18 x plus 3 all over 1? Yes, what will cancel out? The 6 will simplify with the 18, leaving me with 3 on top. More accurately, it leaves me with 5 getting multiplied by the 3 and the x plus 3. Here's my equal sign. Third one, cross simplifying is going to be the 18s. And I will be left with 23 and x plus 3 every single time. When I do this process, the denominators will cancel out completely. I'm left with a much easier equation that I now know how to solve. If I want to solve this equation, where am I going to start? I could sit up here and entertain myself while I wait for answers. Simplify. Simplify what we can. 4 gets multiplied by 18, giving me 72. Plus 5 gets multiplied by 3, giving me 15, which also needs to distribute. 15 times x, 15x, 15 times 3, 45, equals 23 needs distributed. 23x plus 69. Simplify further, combine some like terms. 72 plus 45 happens to be 117. Okay, subtract 15x, subtract 15x. At the same time, I'm going to subtract the 69 from both sides. I'm going to get 48 equals 8x. X is 6. There's one more thing we have to do before we call this done, though. And that is check for extraneous solutions. It's been a minute since we've talked about extraneous solutions, but you would have talked about them back in Algebra 2 or Advanced Algebra. Does anyone remember what an extraneous solution is? Extraneous solution is a solution that doesn't actually fit the original problem. So one of the things I'll write this down first. Now this does assume that you solved correctly. If you solved incorrectly and the number doesn't work, that's not an extraneous solution. It's just a wrong answer. So one of the things that happens as we're solving equations by opposite operations, we tend to ignore the fact that the original problem may have had some limitations of what it could be. With rationals, when we take a rational equation, a bunch of fractions in an equation, and we do this process, or any solving process, we change it into an expression that will be linear or quadratic, or sometimes it'll even be more complicated and be cubic or quartic or quintic. We're not going to get that extreme. We're going to stick with either linear or quadratic. but we change it into something that's just a polynomial, into something that's just variables with exponents and numbers getting multiplied and added and subtracted. We've gotten rid of the fact that division was part of the original problem. Adding, subtracting, and multiplying, there's no limitations on them. You can add anything, multiply by anything, divide by anything. It's not going to change your problem. Or sorry, subtract anything. Dividing does have a problem. What are you not allowed to divide by? 0. Dividing has a limitation that we ignored. So we have to make sure that the answer we get doesn't cause issues with that limitation. Essentially, we got to make sure it isn't an excluded value. We've got to make sure it doesn't make the denominator equal to 0 anywhere. So my x was 6. My first fraction was x plus 3 in the denominator. Is 6 plus 3 going to be 0? No, not a problem. The second fraction was 6. Just 6. Is that denominator going to change regardless of what x is? No, 6 is not 0. Third one's 18. Also, just a plain number, not going to cause issues. I just have to double check that it doesn't make any of my denominators equal to 0. Since it does not, that is a true solution. If it does make my denominators equal to 0, then it's not actually a solution. Okay. One over p minus 2 is equal to 2p minus 1 over p squared plus 2p minus 8 plus 2 over p plus 4. It is an equation. It's got an equal sign. Miriam, if I want to solve, what is the first thing we try to do on these problems? Find the least common denominator. Aubrey, if I want to find the LCD here, what do I have to do before that? Factor top, bottom, or both?
Or bottom.
Just the bottom. Leave the numerators alone. Okay. Burton, can I factor any of these denominators? Which one? Those ones don't factor. Two things that multiply to negative 8 but add to 2? 2 and 4, which one's negative to make it work? Perfect. So, this denominator becomes p minus 2 and p plus 4. Hannah, what does that make our LCD? You're not Hannah. P minus 2p plus 4. That takes care of everything in our denominators. Kylie. Freitag. Now what? Multiply by the least common denominator, every single fraction. Austin. For what purpose? Now what, in other words? Cross simplify. Cancel things out. P minus 2, dead. P minus 2, P plus 4, both dead. P plus 4, both dead. Be careful at this point. What you're left with, often people lose things. Alex, what are we left with? Technically, there's a 1 in front of it. A 1 wouldn't make a difference on this problem, but sometimes it will. Sorry, I interrupted you. Continue, Alex. I am going to wait to distribute, and there is a major reason as to why I do that. Happens in adding and subtracting as well, but especially in solving. If you are distributing, you might have to distribute a negative with it. I highly recommend you wait till distribute until after this, because had this been a minus, you would have needed to distribute -2. So be careful of that. Is it a minus? No. I distribute, and this time around, it wouldn't make a difference had we not done so, or had we distributed. Other times it will. From here, we just do what? Simplify and solve. P plus 4 equals 4p minus 5. Minus p plus 5, 9 equals 3p. Therefore, p is 3. Adela, before I am done, what do I need to make sure I do? Check for extraneous solutions. Make sure that p equals 3 will not make any of the denominators equal to 0. You can look at the factored form for this. 3 minus 2, is that 0? No. I could plug into this original denominator, but if it doesn't make any of the factors 0, it's not going to make the original 0. 3 minus 2, we already established, is not 0. 3 plus 4, is that 0? 3 plus 4 is still not 0. That is the solution. I've got one more example and then just one quick follow-up. X over x plus 5 minus x squared minus x minus 10 over x squared plus 8x plus 15 is equal to 3 over x plus 3. Isaiah, what would you tell me to do first again? Find the least common denominator. In order to do that, Ellie, what do I have to start with? Factor top, bottom, or both? Just the bottom. X plus 5 does not factor. X plus 3 does not factor. X squared plus 8x plus 15 factors into x plus 5, x plus 3. Have you noticed that there tends to be some factoring that matches denominators that currently exist? That is a common thing that happens. Does it happen every time? No. Will it happen a lot of the time? Yeah. So LCD, x plus 5, x plus 3. beta. What do I do next with that? Multiply each of the fractions by that LCD. The purpose being we can now cross simplify. X plus 5s are gone. X plus 5 and X plus 3 on the middle one are both gone. X plus 3 on the last one is gone. Jack, what's left over? Multiplying what? Good catch on that. If it's got adding or subtracting, it's technically in parentheses. The last problem, it had that. I didn't talk about it because there was nothing to distribute into it. But that 2p minus 1 technically was in parentheses. Sorry, I interrupted again. Beautiful. I distribute 2x times x is 2x squared. 2x times 3 is 6x. Negative x squared plus x plus 10 equals 3x plus 15. Combining like terms on each side, I get an x squared plus a 7x plus a 10 is equal to 3x plus 15. Now, anytime I see an x squared, I hope it's kind of like last week's skill builder where the x squareds cancel out. Is there x squareds on both sides that are going to cancel out? No. This is a quadratic equation. To solve quadratic equations, they must be equal to what first? Zero. Because to solve quadratic equations, we are going to want to do things like the zero product property, which requires things to be equal to 0. Or we want to do quadratic formula, which requires things to be equal to 0. Now the hope is that it factors, because factoring does tend to be faster. Wendy, can I factor x squared plus 4x equals negative 5? Yes, two things that multiply to negative 5 but add to 4 are 5 and negative 1. X plus 5, x minus 1 equal to 0. And then I can split. This is called the zero product property. The only way you can do the zero product property is if it's equal to 0, because they have to multiply and give you 0. I get x equals negative 5 and x equals 1. Ruby, before I'm happy with my answers, I do what again? Check for extraneous solutions. Make sure that neither of them makes the denominator equal to 0. X minus 5 is negative 5 plus 5, 0. That's extraneous. Doesn't mean the other one will be, means this one is. I cross it off. It's not an answer. I go to check 1. 1 plus 5, is that 0? 1 plus 5 still not 0. 1 plus 3, 0? No. 1 plus 3 still not 0. This is my solution. What if both of them were extraneous? What would be my answer? No solution. It's asking you to solve, which means you can tell me it is no solution if there is not a solution. So, I said I had one more example and one other quick thing to talk about. Sometimes quadratics don't factor. If a quadratic equation does not factor, that's where the quadratic formula comes into play. Are you going to need to use the quadratic formula a lot? No. Hence the reason I'm not going through a big thing with it. But you do need to know what it is. Quadratic formula, if you do not recall, looks like this. Where it assumes that the equation's in the form ax squared plus bx plus c is equal to 0. Do remember that when you're given an equation, we're not going to go through a full example of this, but let's say we were given x squared plus 4x minus 5 equals 0, and we couldn't figure out how to factor it. We make sure it's equal to 0. And then a, b, and c are just the numbers in front of the x and the constant. Do not forget to bring positive and negative with. Plus and minus would give us the two answers. If you do not remember how to use the quadratic formula, then we should probably talk about it. But most of your problems are not going to require it, if not all.